Hello, good morning, good evening. I'm Anthony Shaw, and we're going to talk today on Learn Live about data-driven AI applications and multimodal search. I'm going to be showing you a demo that I've been put together, which is like a store that's got some AI in the back end, and I'm going to explain how AI can serve a role in like a search capability for a traditional e-commerce store, but like this same rule idea kind of applies in any kind of app. So the target audience for this presentation is anyone who's kind of familiar with AI, but not in the deep technical details in terms of like how to use vectors and embeddings and how to work with different prompts and stuff like that. So before we kind of get started, I just want to set a distinction between machine learning, which we've been doing for a long time, and artificial intelligence, because these two terms kind of get chucked in together nowadays, and people talk about AI when they're kind of really talking about machine learning or spotting patterns or regressions and things like that. So machine learning is a type of AI that uses mostly statistics and algorithms to calculate or predict information. And we can use that for things like modeling. We can use it for things like classification, so identifying like types of information, or machine learning is often used for like images and looking at patterns in images for medical studies, or it's used for looking at natural language and understanding text, or we use it for statistical modeling for things like analyzing the stock market or looking at like outputs of machines and stuff like that. It is highly sort of mathematical based, and it's based on algorithms which have been tried and tested for decades and developed. This is an interesting field. AI, on the other hand, can kind of perform slightly more complex tasks, such as understanding, which I've put in quotes because it's debatable whether the AI really understands something, but it can understand natural language. It can do things like recognizing faces or emotions and making recommendations. So it's kind of like the bridge between the algorithms and like the interface, so that us, the user. Large language models are now kind of one of the huge talking topics over the last couple of years, which is LLMs and GPTs and how that serves a role in AI. They are a form of AI. They're not the only AI. And AI can involve machine learning, and actually mostly does use machine learning algorithms to actually deliver the capabilities such as perception, reasoning, and natural language processing. So machine learning and AI, we kind of talk about ML and AI as being two different kind of fields or different areas, but they're not mutually exclusive. Like machine learning is often used to train AI models, and if you look at how AI works, machine learning is at the core of it. So I just want to kind of set that distinction first before we jump into some more details. So another thing, I mean, actually I'm giving a talk this week at a high school, and I asked the students, they're in the 8th grade, so this is 13, 14-year-olds, how many of you use ChatGPT? And I think almost every single one put their hand up. The technology is prolific. I think that when people look at AI now, they think about these kind of chatbots and LLMs, especially consumers. So, you know, I've been developing for quite a long time now, but been working with AI, or what was AI, and machine learning for a couple of decades. And LLMs are not the only form of AI. But now when I talk to users or consumers and I talk to them about AI, they are now starting to think about these chat interfaces like ChatGPT or Copilot. And ChatGPT is not just the model, it's an application built on top of that. So, you know, you have to log into it. It has a web interface. It has something called a tokenizer, which takes the text from the user and then feeds it into the model. And then it also has a system prompt. So ChatGPT has quite a large prompt that tells the chat model how to behave as ChatGPT. We have a different prompt for Copilot in Word, for example, or Copilot in Outlook, Copilot in SharePoint. So any of those other Copilots they are basically different applications, all built on the same core technology, but they have different prompts and they are different applications. So I do want to set that distinction because often people are kind of bundling just the topic of AI with chat apps, and that's not really the whole story. Talking about OpenAI in particular, OpenAI actually has a lot of different models, and they perform or they can do different things. So GPT is the one that's used for ChatGPT, and there are different versions of the GPT model. Often, so if you're using Bing Chat, you can switch or you can choose whether you want to use GPT-4, which is one of the newer models. The newest one for GPT is GPT-4o. And there are two flavors, I guess, of that model. There's one which is for complex multi-step tasks, or where you've given it a lot of text to analyze and respond to. Or there's the mini model, which is fast and lightweight. And we're actually going to be using a bit of GPT-4o and a bit of the mini model in the talk today and in the demo I'm going to give you. There's DALL-E, which is really fun, which you can use to generate or create pictures or images based on a prompt. So if you use Bing Create, that's what is being used behind the scenes. TTS, and Whisper, which is kind of about working with spoken audio and converting that into text and vice versa. We've then got embedding models, and these are really interesting technology. And this is actually going to be one of the focuses of this talk, is the embedding models. And I'm explaining what an embedding model is, how we work with vectors, and how that technology can be used to enrich or improve a search capability in an application. There's also models for moderation. We use that to look at whether text could be sensitive or unsafe. And those models are used for things like Copilot and ChatGPT. So large language model. So an LLM is a model that's so large. We talk about the number of parameters it has, but that's kind of jumping deep into the science. It is a model so large that it achieves like a general language understanding and generation. And the way I kind of think about LLMs is being a model which can predict the rest of a sentence or the rest of a paragraph. And you tell it a story and it will finish that story for you. We call the parts of the story the prompts. So kind of like the first prompt would be the instructions to the LLM. As far as the LLM is concerned, it's not understanding or comprehending the instructions. It sees that as a story which it has to finish. So just as you asked, if you asked a student, okay, I've written the first 3 chapters of a book, can you write the final chapter for me? They'd read the first 3 chapters, they'd understand who the characters are, what's happening, what's the situation, what's the premise of the book, and then they could finish the final chapter. The quality of the final chapter is probably going to depend on the quality of the first 3. So the better you can make the prompts, the better you can have a response or a really useful answer from an LLM. When you're using something like Copilot Chat or ChatGPT, you can't see, but there is a prompt behind the scenes, which is kind of set the first part of the story for the LLM to fill in and respond to. So we've kind of told the LLM beforehand, this is how we want you to respond. This is how we want you to behave. This is how we want you to kind of like comprehend what the user has asked for. And then when you get a response back, we're hoping that's closest to what you meant. And one of the big challenges with working with language and working with LLMs is that as humans, we can be really, really vague sometimes. We can say one thing, but actually we meant something slightly different. If you've ever been in a situation where you've been texting a friend and they've completely misinterpreted the tone of what you've said or what you meant, this is a huge challenge, especially with text, because so much of what we convey is in body language and tone and voice. And just moving from that to just purely working in text is quite a challenge. And so we have to provide the LLM with a lot of context, which is called prompts. And then, it will kind of vary its responses. They're also non-deterministic, which means that the LLMs will provide a slightly different answer each time because they slightly randomize the sort of sequence of words that they have. Some popular LLMs, the GPT models, GPT 3.5 and GPT-4. There's Google's Gemini models, Claude 2 and 3 from Anthropic, Llama from Meta, Mistral and Mixtral, and Phi 3 or Phi 3.5, I think, is now available as well. So it's not just GPT. That's not the only LLM out there. There are lots of different types of LLMs. And in the AI Studio, which I'll kind of give you a glimpse to in a bit, you can actually play with and experiment with the different LLMs. So there are some limitations with LLMs as well. They don't have, so if you ask it a question, like what's the weather going to be like today? Two things. One, it doesn't know. It was trained on data from 6 months ago or a year ago, depending on which model it is. So it doesn't know. And secondly, it doesn't know where I am. But like I said earlier, it's all about kind of finishing a story with the LLM. And often, if you've kind of set the first part of the story, which is, oh, you're a really helpful assistant that answers questions, and the sentence that the user has asked is, tell me about the weather, then the LLM will think that you want it to tell you about the weather. And it knows how to respond to a question about the weather. It will just say, it's sunny today, or like, it's going to rain at 3 o'clock. But it's doing that because it's finishing the story. It's not checking the weather charts. It's not speaking to the Bureau of Meteorology here in Australia. It is trying to finish a story. And that's why we have to be careful when we work with the prompts to tell the LLM, as part of the kind of the background story, I guess, for the LLM, is that, yes, you are a helpful assistant, but if there's something that you can't determine because it's recent or it needs to be looked up on the internet, don't make it up. Don't tell the user it's going to be sunny if you don't know it's going to be sunny. So this is a super important fact, and something that you have to work with LLMs. There are 3 techniques you can use to kind of improve LLMs so that they can understand or they can reply about what we call domain knowledge, but that's other information. So that could be the good example is always the weather. Everyone loves that example, but I'm going to show you some stuff which is slightly different, which is more about search and how we can use search capability. But domain knowledge, you can use 3 things. One is prompt engineering, which is when you kind of create the prompt, you can give it some extra information in the prompt, and I'll show you how to do that. We can do something called fine tuning, which is kind of where we take the base model and we actually retrain it with some new skills. To do this is quite expensive because you have to use all the GPUs to retrain the model. And also you have to have a lot of data to do that. So you can kind of make your own model, or you can build on top of a base model with additional capabilities. And those are things that we've done with stuff like Copilot, for example. So we've kind of optimized those models for specific tasks. And then the other one, which is kind of similar to the first one, which is retrieval augmentation, where you find some information. The user asks a question, you find some information, and then you put that in the prompt. You include that in the prompt. And that's the technique we're going to use in this demo. And I'm going to show you now this app. Here's a QR code for the source code for this demo if you want to have a look. I've tried to keep the code for this as simple as possible because there's really kind of 2 techniques I want to show you with AI in this demo. It is a Python demo, but you could apply the same techniques to any other language or any other framework. So I'm going to switch. Okay, so I've set up a really, really simple like e-store. So I've got a home page. I actually made this with GitHub Copilot. So I'm not a very good UI developer. I'm a backend developer. I work in Python. So I asked it to create a Tailwind CSS page for me, and I created just this home page with some fictional products inside it. So I've got a database with some products. And again, even those products, actually, I asked the AI to make for me. So in Copilot chat in Visual Studio Code, I said, can you create some fake data for me? Like the things I want is a name, a description, and a price. Like those were the things I wanted. So I wanted to create a store with some products in it, some clothes. And I've created this with a really simple database with like a t-shirt, some hoodies, like a dress. And for each one of the sort of fake products that the AI came up with, I copied the description. So like it came up with a description for the Azure Dream t-shirt, and I copied that description and put it into Bing Create, and then said, can you create a photorealistic image of a product that kind of matches this description? So that's how it produced that for the Azure Dream t-shirt. Like this is what it came up with. That's like Azure Blue, that color. So I use this basically to create a store with just 16 products, and each one. So we've got like the red hoodie, we've got some green shorts, a blue jacket, just some really kind of basic products that we can have. And each one in my database has got a description. So I've got a description of what this is. And this is kind of what you typically have for something like a store. So we've got, a hoodie here. It describes it in plain English, and the user can go in my store and they can type in a search for hoodie. So they can look for a hoodie, and that will come back and give them a hoodie. That's like the first answer it comes back with. Now, that's not very impressive. That's technology that's existed for 24 years. Now, where AI can kind of come into this is like users are not always really specific about what they're looking for, or in order for a store like an e-commerce store to have a really effective search, someone on the back end needs to provide like a lot of metadata. So like, what color is this? What type of clothing is it? Like, is this for men? Is this for women? Is this a unisex hoodie? Like, is this for cold weather? Is this for warm weather? Like, you'd have to provide all these different bits of metadata in the database. And especially if the store was like a bricks and mortar store and they already had all these products, sitting around in the shop, and they wanted to turn it into an online store, someone's got the arduous task of sitting there typing in all that information. So what I wanted to do with this first part is to say, okay, like what could I wear, something to wear on a cold day? And that like is not a typical like thing that you could just look up in a database, right? Because it doesn't say something to wear on a cold day in the database. But what we can do with AI is we can kind of try and work out the sentiment or the meaning of what the user has searched for and match that as closely as possible with things in our database. And we do that using vectors and similarity. And that was one of the models that we looked at before. I'm going to explain that in detail, like how that works. But it's come back to me with a crimson night hoodie. And that's probably because I've said in the description that's a warm hoodie. So it's come back with a blue jacket, perfect for windy and rainy days, which is when it tends to be quite cold. And it's come back with a scarf as well. So those are actually pretty good suggestions. And it's also come back and said, like, that's what it's searching for is cold day. And I'll show you why in a minute. And then the other feature that I implemented using AI was I've got some images, like pictures. And what I wanted to have in this app, in this website, was the user could take a photo that they've seen in like a magazine or something of like an outfit or some clothing, and they want to find, what do you have that's like this? And so I've got two pictures I want to use for testing. One is this one here, which is a man wearing like a green and yellow sort of like plaid shirt and some jeans and some shoes. So I've only got 16 products in my database. I probably don't have anything that exactly matches that, but we can have a look to see like what's the closest. And so if I say match outfit, the AI is going to do a different type of search, but it's going to search the database and it's going to come back with the closest things that it can find to what that person was wearing, which is a green and yellow flannel shirt. It is a slightly different pattern, but it's pretty close. I don't have a pattern that exactly matches that particular type of blade, and it's come back with a pair of jeans. Those are black jeans. This man is wearing blue jeans, but I didn't have blue jeans in my database, so that's what it's come back with. That's a pretty good guess. Like that's a pretty solid kind of recommendation to the user. So the idea was that the AI could provide a capability that would be really difficult for us to kind of write and figure out, or the user would have to sit there and type in, oh, do you have anything that's like a shirt? And then, they'd have to describe it for you. And then the other test image I've got is this one here, which is a woman with a denim jacket and like a green backpack. It's a side profile as well. So this is actually quite difficult to work with. And, there's a blue background and a pink background. So I can drop that one into the search and do a match and see what it comes up with. And it's going to come back with a green backpack. It's not the same one, but again, like I don't have that particular backpack in my shop. I don't know where it comes from, but that's the closest thing we have to what you were looking for. Like it's an olive green backpack. It has a leather buckle on it instead of this one doesn't have any buckle. And there's a denim jacket. Like this is a slightly darker blue, but it's a pretty good fit, and it's a pretty good estimate. So if we did have a lighter blue denim jacket in our store, it would come back with that as the recommendation. So I'm going to explain to you like how that works. And one thing I want you to keep in mind is so far I've shown you 2 AI integrations and there is no chat feature. I haven't put a chat window on the side. There's no bot on the side where you have to type in what you want. This just feels like and looks like an e-commerce store, but we've actually used the GPT model in the background. We've used the embeddings model and we've used the computer vision model. So we've used 3 AI models in this capability. But as far as the user is concerned, they're not interacting with the chatbot. They are just looking for clothing on a clothing store and they're typing in a search. And people know how to do that. They've been doing that since like the late 90s. People have been interacting with online stores. They know how to do searches. They can often be quite vague. But this match outfit kind of thing is a new feature, I guess. So I'm going to continue with my presentation and then cool. So to achieve what we just did, we're going to be using a technology called vectors. And I wanted to give you an overview of what vectors are and how they work, and then how that could be applied into the store that we had. So a vector, there's kind of 2 terms that are thrown around. A vector embedding. An embedding is something that takes an input, which is a list of floating point numbers or like decimal numbers, and they range between -1 and 1. I'll explain why they do and like where they came from. But when you hear the word vectors or vector database, really what it is a list of numbers. And I think the easiest thing is to think of those numbers as like coordinates in like a space. So just as you were working with, like if you were working 2D, for example, in like a map, and you were looking at coordinates and you were looking at a map of the US, and you had somebody in Florida and you had somebody in like Mississippi, and those would be different coordinates. And you'd say, how similar are those 2 places? And you could look at that by measuring the distance to them. So like how close are they together? And that's similar to what we do in vectors, which is we have these coordinates or embeddings. And then we can calculate like how similar they are by how close they are to each other in the space. There's different models for doing that. The most popular one has been OpenAI, the catchily named text embedding ADA002, which is the 3rd one on my table. This one has been popular because it is the embedding model that's normally used with ChatGPT 3.5 and GPT-4. OpenAI announced new models a few months ago, text embedding 3 small and text embedding 3 large. The difference between those models and the ADA model is 1, they are faster, and 2, they are cheaper. So, it basically does the same thing. Actually, much more effectively. So in terms of its performance, those models are faster, better, and cheaper, which is a win-win-win in my mind. So whenever you're looking at embeddings or you're doing vector work, I strongly recommend you look at the new text embedding 3 models. The small model in particular outperforms the old Ada model with smaller vectors, better performance, and about a tenth of the price. So I strongly
Anthony, we do
look
have a
at that.
question from the audience.
Yeah. Uh,
John is asking, why are there negative embeddings?
I think it was more to do with the like the efficiency of the in a floating point. A minus or without the minus is just a bit in a float, and that's really easy to like it compresses well. It's a technical reason more to do with the like efficiency of how the minus is stored in the floating point number. So it's a range between -1 and 1. The other thing as well is the angle, which we'll get to in a second, is measured from one point to another. And if you have something that's minus, that's behind, then you can have an angle that's up to 180 degrees. So I'll explain that in a second.
Awesome. Thank you.
So we talk about similarity, and I guess my kind of first example is if you think of a 2D space, like a map, and you say how similar are these things by working out how close they are together. That's one way of looking at it. The challenge is that, if you said how similar are, okay, let's pick on Florida because I mentioned that one first. How similar are Miami and Orlando? They're close to each other relatively. But in terms of like other factors, they're pretty different. Like Miami's by the beach, Orlando's in the middle of the state. Orlando has a lot of theme parks. Miami has a lot of shops and beaches and clubs and stuff. So like they are different, and you can't just have 2 dimensions to work out how similar something is. When we're working with AI, the similarity is either a word or a sentence. And so when I typed in something for cold weather, it kind of associates warm, like that was the warm hoodie, and cold weather. Those are similar things because they're talking about temperature, they're talking about weather. So it puts them in a similar space in its model. So what an embedding model is it's basically like a huge space where you can give it a piece of text and it will give you the coordinates of that bit of text in that space. And then you can give it another bit of text, like a sentence or a word, and then it will give you some other coordinates, and you can then work out how close are they to each other. We've drawn this in like 3 dimensions here with some words like house, computer, tree, dog, God, king, cat, because 3 dimensions is a bit easier to visualize. But actually, the AI works with more than 3 dimensions. It works with, well, depending on the model, hundreds or over 1,000 dimensions. That's impossible for us to visualize. Like our brains cannot, work that out. So it's easy for me to explain it in 3 dimensions, but it's actually more than that. So vector similarity or embeddings is a way of getting like the coordinates of a bit of text in this space that the AI uses to work out how similar things are. So when we do vector search, the first thing we do is calculate the embedding vector for the query. So let's just call that coordinates for now, because I think that's an easier term to work with. So step 1 is like get the coordinates for the thing that the user typed in. And then step 2, like get a pencil and then like draw around that area and that coordinates, just as if you were looking at a map, and you found like the town that you wanted to go to on the map, and you said, find me everything within 5 miles or 5 kilometers of that town. So you could get a compass and you could draw a circle around it and say, okay, here's all the things which are within 5 miles of that. That is the closest vectors or the closest nearest neighbors. You might hear that KNN sometimes mentioned, which is basically saying like what's in that area. So with the vectors, what we can do is we can type in our query, we can get the embedding vector, which is our coordinates. We can then look at what is in the area, and then it will give us back some other points which are in the area. So, for example, if we typed in tortoise and we use one of the embedding models, the OpenAI ones, it would give us back that list, that set of coordinates, and then we can search for existing vectors. And it would give us things which are similar to tortoise, like snake or frog or turtle would be probably a better one. So like these are reptiles. So, it's put them in the reptile space. These are, things which are kind of green. So it's put them in the sort of green space. And they've got all these neighborhoods in the model where they've put bits of information which are related to each other. The model has been built in a way based on what OpenAI was kind of trained on. So they've kind of got these clusters or like neighborhoods, I guess, of bits of information in the embeddings. So I try and think of it in 3D because trying to picture it in hundreds of dimensions is impossible. But think of them as coordinates, and you kind of got these spaces where you can look for information. So in Azure, we've got a couple of options. We've got vectors. You can store vectors in a database, and I'll explain why you would want to do that in a minute. You can do this in Cosmos. You can do this in Postgres. You can do it in Fabric and SQL Server. That capability is in preview, or going to be in preview pretty soon. And then we've also got an entire product called Azure AI Search, which is built for taking existing data from pretty much anything you can think of, like PDFs, Word documents, PowerPoints, blob storage, SQL databases, and then like attaching a vector or like an embedding to it. So you've got all your data in your database, and it will go through each record in the database and then create the coordinates of that bit of data. And then you can say, okay, find me, products like this. And that is essentially what I did in that demo, was to take the product descriptions for each of the products that I got in my database. There were only 16, so it's quite easy to do, to take each description and then get the embedding or the coordinates from the AI model, store that in a database. And then when the user types in their query, I get the embedding of that. And then I compare it and say, like, what is the closest thing I have to what they asked for? It's a different way of thinking of search, because normally when you think of search, like, like an internet search or a database search, you're looking for words, like exact matches to words from the query in the database. And there's some that is sometimes really effective, but often like you've got people asking questions in different languages. You've got people being kind of vague. Maybe they're not using the exact name. Like this morning, I was shopping for a camping stove. We're going camping next weekend, and I'm looking for like a gas stove, and I can't remember what it's called. So I'm just typing in Coleman gas stove, and it's giving me some matches based kind of what I'm asking for. But I'm not specific. I'm not typing the exact name of the product because I don't know what it is. Coleman have decided to call it fire breather or something ridiculous. But as a consumer, I've got no idea what that is. I just want a gas stove that's going to work near the beach, so it's always windy. And I can type in like, what's a good camping stove for like a windy place. So we've calculated these embeddings, these vectors or coordinates. Let's keep calling them coordinates. We've got them, and it's just a series of numbers. So like, why do you need a special database to do it? I mean, technically you can, and in my demo, actually, I've got an example of a homemade vector database. Like it does the job, but you can use it locally. It's really slow and really inefficient, but it does the job. You could store a vector in any database. It doesn't need to be a vector database. The problem is you can't efficiently search over it. So you've got these vectors, and the way we do the search is basically, like I said with a map, if you just draw a circle around it, that's easy to do in 2 dimensions. But when we're talking about 1532 dimensions, that's actually quite a big calculation to work out like the positions of every single dimension and then rank everything that we've got in the database and order it and sort it. So the vector database, actually most of the technology is on the like the similarity algorithm and the calculation and then ranking the results. So when we say vector database, it's actually because you've got a special column type. So, previously you'd have, a text column or for my price, like that's a number column or like a currency column. And you've got a special new column type, which is a vector. And you've got an index, which you can use to efficiently search over vectors with different algorithms. Some vector databases also give you the ability to calculate the vectors. Like you don't have to do that; it does that for you. So it can talk to the AI model for you and create those numbers. Or they've got like additional algorithms to do search and filtering.
Anthony, we do
And
have
I'll give
another
you,
question, if you don't
yeah.
mind, just a moment before we move on. Extreme Curs has a question. How do vector databases handle large-scale transactions, and what optimizations are available for high-throughput environments?
That's a great question. So I actually think a vector database as a database with a vector capability. They are not new types of databases. They are really just a category for a database server that also supports vectors as a column type and also as an index. So like that's the minimum capability for a vector database. So SQL Server, you can store a vector in SQL Server. Cosmos, which will like Cosmos DB, which is what I'm using for my demo. I'll show you that one. So that has all the throughput, all the scalability, all the geo redundancy, everything that's already existing. It's just that now you can have another type of index, which is a vector, and you can query that really efficiently. In terms of the efficiency of the vectors, if you're taking a huge amount of data, you do get into details about like there's different ways of storing the vector. You can kind of compress them. I showed you those floating point numbers. Doing like a massive floating point calculation is computationally quite expensive. And there's ways that you can kind of compress those down. So instead of like a 32-bit floating point, you can actually compress that down into a smaller size. And that just makes it more efficient. If you're talking about like millions of rows, millions of records, and that essentially is actually one of the core technologies that we use with things like Bing search. And Bing, we've been doing vector similarity search in Bing for years. And most search engines nowadays kind of use a similar technique. So it does scale. It's just you do need to consider like how you store the vector. There's one more thing I want to cover, which is the like vector similarity is a great technique, but often you need to do slightly more than that. So if I ask the question, what underwater activities can I do in the Bahamas? You can ask this question twice. And this is called a hybrid search, which is where you take keywords. And I have done this for my demo app. So we do a keyword search. So the keywords in here probably would be Bahamas. I think that's the most important part of my keyword search is I've specified specifically Bahamas. And then we can do a vector search, like a similarity search. And those are probably going to come up with different things because the keyword search would say, okay, I found one thing that has Bahamas in it. So like I'm going to match that pretty high. And that's like scuba diving in the Bahamas. Like that's a good result. The vector search would come back and say, okay, here's some similar things. And it doesn't know, it doesn't rank each word in terms of its importance. So like it says similar things: underwater, water activities, Bahamas, tropical places, warm places. Like those are all kind of in the same neighborhood. So it could come back with a result like number 2, which is water skiing in the Seychelles. That's not underwater unless you're doing it wrong or you've fallen in. And the Seychelles is nowhere near the Bahamas. But as far as like the similarity is concerned, the Seychelles is a tropical place. It's like a set of islands. The Bahamas is a set of islands. So like it will give you information like that. And so what you can do is you can merge those results together using like a special algorithm, which is called RRF, but it basically just kind of zips them together. And that would give you like this order. So we'd get like scuba diving in the Caribbean, scuba diving in the Bahamas, and then like it would put water skiing in the Seychelles last. In Azure AI Search, there's an additional capability where we can re-rank the order. Basically, it looks at the likelihood of each result being the one that you wanted, and it would switch number 1 and 2 around. So that's an extra feature that's in AI Search only. And there's an interesting paper about that and how it works. But if you're working with large amounts of data and large amounts of vectors, often this sort of extra fusion step or the re-ranking step can be really important. So let's dig a bit more into the demo that I showed you, because I kind of just glimpsed over like what it was earlier, but let's actually kind of look at how it was put together. So there's a couple of things in here. Actually, let me show you the diagram, because that's going to kind of hopefully put it together. So we've got a web app, which is my super simple. It's only 3 pages. I've got a database, which is in Cosmos DB. I've got this vector search capability, and I've got like I'm using Azure Functions to kind of drive the behavior in the background. So when I type in my search, something for a cold day, then you see here, I've actually got just the keywords. And this kind of goes back to my slide about the water skiing in the Bahamas. Like, often you want to match something in particular. So that's called a crimson night hoodie. So if I just search for crimson night hoodie, I probably want that product first. Like if the user types in the specific name of the product, that's probably what they're looking for. So what we've actually done in this sample is when they type in the search, I'm actually talking to the GPT model. That might seem confusing, like, where's the chat box? Why are you talking to GPT? But the reason is I've got a special prompt. And I put this prompt together because when the user is typing a question, actually, let me give you another example. I've put like a few different languages in here as well. So you can switch to Spanish, French, German, and Japanese and Hindi. Now the database is in English, but like if I typed in, let me switch languages. If I typed in, come on, that says some address, sorry, in Japanese. If I typed in some address, it's going to search for some address. And it's done that because I've got this extra step in the middle. And the extra step is this prompt. And the prompt is basically, like I was saying earlier, it's like a story that you're trying to tell, and it's going to finish the story for you. And the opening part of the story is, I want you to generate a search query for a SQL database based on a user query. Don't generate the whole SQL. Don't generate like a SQL statement. That will end really badly. Only generate like some keywords. Use like Boolean operators if the user has been specific about what they want to exclude in the search. So if the user says, give me something for summer, but I hate the color blue, then I want you to explicitly say, but not blue. If the query is not in English, always translate the query to English. If you cannot generate a search query, just return the number 0. So this is actually a prompt that I've given the GPT model, GPT-4.0, and I kind of experimented with this prompt in the chat playground. So I mentioned that there's lots of different types of models that you can do. And in Azure AI Studio, you can come in and you can deploy, like I can, from here, oh, that's the one Satya announced today. So O1 Preview and O1 Mini is now available. GPT-4o and GPT-4o Mini. So when you're doing this kind of like query prep, prompting, stuff like that, I'd recommend using 4o Mini because it's cheap, it's fast, and it's effective, which is a win-win-win. And that model, and I'm using 4o, the full 4o here, is great for this type of task, which is like, I want you to take a user question, a user query, and make it into something I can search in a database for. And in the playground, I can then say like, generate, oh, I've still got Japanese keyboard on. Generate a user query for, like, best cheeses from France. It's a controversial question. It would say best and cheeses and France. Like, that's what it's come up with, and that's a pretty good guess as to like a keyword capability. I've then gone a little bit further here where I've given it a bit more of the story. So I've said, here's an interaction. So when I'm talking with the completion, you can do this in AI Studio as well. If you go to, I think it's in examples, that's it, that's the one. You can kind of give it an example interaction. So like, the user said this, and you should have said this. Like, that's what you were doing here, and you can add a few examples. This is called few shot training. It's basically a technique where you're just adding a bit more context to it and saying, like, here's how I want you to behave. If they type in a really nice winter jacket, I want you to respond winter jacket. If they typed in summer dress again, then I want you to say summer dress. So like, it's you've given it some examples, and therefore what it's doing is going to be close to what you want. So it's then spat out this keyword for me. So it's got the thing that it's looking for, the keyword search. In our database, then what we need to do is we need to calculate the embeddings, the vectors for like the product descriptions. So like, that's the name and the description. So we can do that using the text embedding model. And what we do is we basically go through the database, and we create an additional index or an additional field, and we put the embedding in there. I've done that in Cosmos because that's an easy one for me to work with, and I've specified I've got two embedding fields. They're both floats. They're both 1024 dimensions. One of them is the description, and one of them is the picture, like the image. And then in my code, I've also said, like, I want you to index those. So when I do a query, I basically say, like, use the embedding as the thing that you're measuring. And the cosine similarity is one of the ways of calculating things in that area, or things that are most similar to it. And then in the app, when I've got the search feature, I'm going to do like a couple of things. So I've got my search query that comes in. That's the thing the user typed in. So it's like, step one is to take the query, give it to GPT. So it does that stage where it kind of rewrites the query to make it more keyword looking. Step two, which is where I get the embedding, which is, you just call an API. Like, there's no maths involved. This is great. Like, you just say, okay, I want you to use text embedding 3 small, I think I'm using here. Call the API, get the data, and then get that back. And then the last thing I've got is search products, which in my case, I'm using Cosmos to do a search, which is just down here. Basically, it's a SQL query where there's a special field that's called, that's the keyword search. And then I've got a vector search, which is basically calculate the distance. It's like a function you put in the SQL query. In the sample as well. Yeah.
Sorry to jump in. If we do have about 10 minutes left, we did have another question. Is it okay to ask? Perfect.
Yeah.
And apologies in advance if I butcher any parts of these questions. So Nicola is asking, Microsoft Research and Intel Labs used LanceDB OpenSRC vector database implemented in Rust for low latency searches of image frames and videos. Have you done benchmarks comparing Cosmos PG MS SQL?
Okay, so comparing those three technologies, I guess I think your question is like the comparing them, like how quickly they can calculate the distances. I have not. Somebody may have done already. I can have a look later, and maybe I'll share with you, Anas, like if I'll find any resources, like whether someone has done that. As far as the vector database is concerned, they're all using the same set of algorithms. They all use the same calculation, and the vector, like you have to compute the vector. So like in the code here, I'm fetching the embedding by calling OpenAI's API. Like Cosmos is not doing that for me. I have to go and get that from the API and give it to the database. So in my database, I've got the vector information for the products, and I've created that ahead of time. So I've basically copied that text, got the embedding, put it in the database. Now, the other thing we've got in here is, I had it still open. No, I didn't. The other consideration I wanted to mention is that if somebody changes the description or changes the product, like you want to update the vector. And this is kind of an additional step, which is like in Azure Functions, this is why I've picked Azure Functions, because if I go down a bit, I've got some extra code here. Okay, so this is an extra bit of code that I've got, which is a Cosmos DB trigger, which is called whenever someone changes the data in the database. So like I'm assuming that they've changed like the name or the description of the product, and therefore like the coordinates, the vector, needs to be updated. So this is basically a callback code, which is like Cosmos will call my function and it will run this custom bit of code to go and fetch the embedding again from OpenAI if it's changed. So like it sees, okay, did you change the name or the description of the product? If you did, let's go and update the embeddings and store that back in the database so that next time you do a vector similarity search, it's going to give you the right results. So considering we've only got a few more minutes left, so that's the kind of query prep and the similarity search stage. Now the other one, let me change back to English, is the matching. So this one, I've done two implementations of this to kind of show you a difference between, because we said we're doing multi-modal search. So multi-modal search basically means that you've got not just text, you can do images, you can do videos, you can do audio, whatever that looks like. And so in this image here, there's two ways of doing this search. One is that in the playground we can actually do attachments. So like if I do attach that, describe what the person is wearing. Like this is a prompt. GPT-4o, the new Omni model, will like look at the image and then using like classification, how it's been trained, it will then come back and say like they're wearing a light blue denim jacket with a patch on the front. They have a green backpack with a pink fluffy keychain attached to it. They're also wearing a wristwatch. So it's described that for me. Now, what I wanted to do in my search was search for products like what the person is wearing. So when I do a match, what I actually did in the code was to do what I just showed you in the studio, so in the playground, was to basically just make a call to GPT-4 and say, describe what the person is wearing and attach the picture. So that's all I've done. I've just done that behind the scenes. So in this match, I've said, generate a text description of the clothes worn by the person in the image, and then I've included the image that the user uploaded. So it comes back with some text. We calculate the embedding of that text, like the position of the text, and then we do another similarity search. So we're basically doing the same thing that we had on the search page, but this time the text that we're using to search is this text, which is the person is wearing a denim jacket. So it's going to match. It's going to match the green backpack. It's going to match the denim jacket. So that is like the text version of this. I've seen some limitations, like if you're just doing text descriptions to do search, it won't necessarily find like all the characteristics. Or if you actually, sorry, that was doing images, but if I do text, then it will give me slightly different results, I think. Okay, so we've got if we just do text and we use this implementation, it's overemphasized blue denim. So it's got a denim jacket and some jeans. So that is like GPT-4o to describe the image, to get the embedding of the description, and then to search for it. There is another model you can use, which is called Florence, and this is part of Azure Computer Vision. And that one is actually a special embedding model specifically for images. And so if I use the same picture, it will actually analyze different parts of the image and then find things which are similar. So if I use that model, it gives me the backpack and the jacket. Whereas if I just use the text descriptions, it will overemphasize like the denim part, and it will just give you denim products. It doesn't look at like all the characteristics. This is also important with things like, so I've got this person with like the plaid shirt, for example. Like if I use that one with text descriptions only, it will kind of focus on the fact that there's a lot of green in that image. Like, so it said, okay, green and beige shirt, and therefore it's given me a green flannel shirt, which is right. And it's also given me another green t-shirt, which is not what I wanted. So like that's kind of the difference I wanted to show you between the text description approach with GPT-4o and the image embedding using the Florence model, is that the Florence model will focus more on like the actual parts of the image and the patterns, and it will give me some jeans. They're the wrong color, but it's better than a green t-shirt. So yeah, that's what I'd recommend, is to kind of play around with this and to use the chat playground in AI Studio. And then you can kind of experiment with different prompts, give it some different pictures. And that's kind of what you have to do with AI, is you have to kind of start to build up more and more like training data and test data and just kind of experiment with it. And that's what I've been doing for this search and for the match outfit feature. And kind of the point that I want to finish on is that, we've got these two capabilities now in an existing website. Like there's no chat box on the side. We've got a search page. That search page now supports typing in search queries in any language. It could be literally anything. It supports you typing like, find me a like jacket like the one the Fonz wore in Happy Days, if anyone's old enough to remember that. Like that is a ridiculous query to try, and I don't actually have one like that in the shop, but that's closest. Like that it would be extremely difficult to do with just SQL, but GPT can be used to build a capability like that, where the prompting and the interaction is just done in the backend. The user doesn't need to see it. You're just enriching an existing AI, existing application with AI. So if I close on some additional resources that are available to you, that QR code goes to the source code for this demo. So that is using Cosmos DB with a vector index. I've got some the images in there, the products, the descriptions, the test pictures. All of that is open source, so you feel free to copy it, reuse it, whatever you like. And the source code for the Azure function as well is in there. But just kind of have a look at the prompt and what I've done with the prompt to kind of get a steer on how that works. I recommend using the playground as a way of kind of building up how you want to do this type of capability. And then if you want to learn more about vector databases, we've got some great resources to do that. And we've also got more of like a chat application, which is a RAG interaction, which you can give like huge amounts of data, like and PDFs and stuff like that. And then if you want to use AI Studio for more like RAG development as well, then that's another capability to use. So yeah, thank you very much for your time. Hopefully you've learned something new today and you've seen how AI can be used for not just chat applications. We can actually do a lot more for an existing app and add a whole bunch of capabilities that you probably didn't even think were necessarily possible or required like some deep knowledge with AI, but it's really just typing prompts into a backend. Thank you very much.
Thank you, everyone, for joining us. Thank you to Anthony for a fabulous session. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can also find that link on the screen or in the chat. Today's event code is 23495.